In this demo, we'll use Regex to match and extract the sales code and product SKU from our test data in an alternative implementation of product info parsing. We'll learn about Regex Lookarounds, which allow us to assert something before we continue matching. Those assertions require us to look ahead or behind of the current position. We'll use a negative look ahead in our pattern to ensure that certain conditions are not present before we continue. We'll be using the Regex 101 website to assist with crafting our pattern. Inside a Regex pattern, we can use a look ahead or a look behind, collectively referred to as lookarounds. A look ahead is used to check for a condition beyond the current position in the target string. A look behind is the reverse and can check for a condition before the current position. Both forms of lookaround can be either positive or negative. Positive lookarounds expect to find a match for their sub-expression. Only if a match is found will the rest of the pattern continue to execute. Negative lookarounds expect that their sub-expression should not match, so they will only continue when a match is not present. Lookarounds are enclosed in parentheses. A positive look ahead begins with a question mark followed by an equals character. A negative look ahead begins with a question mark followed by an exclamation mark. To identify a positive look behind, we include a left angle bracket between the question mark and equals characters. It's a similar story for the negative look behind. Earlier, we learned about the start and end anchor meta characters. We defined these as zero width assertions, which apply a condition but do not increment the position within the target string. Lookarounds are another example of zero width assertions and do not consume characters. For example, imagine we want to match strings containing the word test when the string ends with a number. While there are other ways to achieve this, we could use a look ahead here. This positive look ahead looks for one or more numeric digits anchored to the end of the string. It looks ahead through the string for a match, but the position is not changed. Eventually, for this first string, a match for the look ahead is achieved. The remainder of the pattern, the literal characters spelling the word test, are then evaluated from the current position at the start of the string. In the second string, the look ahead cannot find a match, so further matching is not attempted, and the overall match fails. We'll continue working in the product info class and provide the final implementation for the parse using Regex method. We'll need a Regex pattern that should match valid product info formats and allow us to extract the sales code and SKU. As we've done a few times, we'll use a string constant to store our Regex pattern. I'll name this parse pattern. As this will be a more complex pattern, I'll head over to Regex 101 so we can visualize our progress. I've prepared this page with a test string where each row comes from our unit test data. I've done it this way so we can see which test data our pattern matches as we build it up. We can now work on our regular expression in the first text box. The first task is to match the sales code portion of the product info at the start of the string. We'll begin with the start anchor to ensure that our match occurs right at the beginning of the string. We'll use a named capture group to extract the code. Our pattern for this part of the match is quite simple. We expect only digits, so we can use the shorthand of / followed by D, which matches numeric digits. We expect at least one digit, so we'll use the one or more quantifier. We expect this code to be followed by a separator. We expect either a colon or a hyphen, so we'll use a character group to specify both as allowed characters. Several invalid strings are already failing to match our pattern at this stage. We'd next like to match and extract the SKU, so we'll use another named capture group for that. We want to match at least one character after the separator, stopping only if we reach an open parenthesis. To achieve this, we can use a negative character group to specify any character except the open parenthesis is allowed. This should match one or unlimited times. Quite a large block is now matched in the test string, which is curious. This is because we have multiple rows of data in this string, which won't be the case in our C# code, where we will process row by row. To work around this for now, we'll add the new line character to our negative character group. This is temporary and we can remove it from the pattern in the C# code later on. We are now matching codes and SKUs for some of the rows. It's a good start but not a perfect one. Our matching becomes a little more interesting after this. In this row, we should handle this special formatting of the SKU. Where it begins with a lowercase letter followed by a hash character, the code is valid, but we don't want to capture that prefix. We can add a non-capturing group to match the prefix when it's present. We expect an English lowercase letter, so our sub-expression can use a character group with a range of characters from lowercase a to lowercase z. A hash character then must follow that lowercase letter. To make this group optional, we add the question mark quantifier afterwards, which matches it 0 or 1 time. In this example, our named capture group no longer includes the prefix. We have 2 remaining matches which are incorrect. This one includes a second hyphen, which is not allowed, and this one has an invalid SKU prefix, including an uppercase letter. To deal with this, we can use a negative look ahead before the SKU capturing group. A negative look ahead asserts that a pattern does not appear beyond the current position. If the pattern is not matched, then the evaluation of the rest of the pattern will continue. Remember, when using look aheads, no characters are being consumed. We define a look ahead or a look behind by enclosing them in parentheses. To define a negative look ahead, we use a question mark followed by an exclamation mark character. We'll look ahead from the current position to see if we can find a hash character that's preceded by 0 or more characters. If this match is not found, then our input string is valid and the remaining pattern can take effect. For this test data, the first part of the pattern matches up until the hyphen character. The negative look ahead runs and finds that there is a hash character later in the string. Because the negative look ahead expects this not to be present, the match fails. Our valid test data still passes. In this example where the special prefix is found, the look ahead runs from the position after the hash. Because no further hash characters appear, matching can continue. Because the look ahead consumed no characters, the final part of the pattern then continues to match from after the hyphen character or the hash character when special formatting is used. We have one invalid test string still being incorrectly matched. We can update the negative look ahead to include a second condition to solve this. We can use alternation by adding the pipe character to represent a Boolean OR condition. We then add a wildcard with a 0 or more quantifier followed by a hyphen. Our negative look ahead looks for either a hash or a hyphen appearing at any point after the current position in the string. The overall match fails if either of these is matched in the look ahead. With this added, our test cases look correct. Our 3 valid codes are matched and the correct parts are captured. We'll copy this pattern and paste it as the value for our parsed pattern constant string. We no longer require the exclusion of the new line character, which was added purely to make things work on the Regex 101 website with multiple rows in the test string. Having completed the pattern, we'll scroll down and perform a match. We'll match against the product info string using our parsed pattern. We won't compile this, but we will add a timeout. We can finish this method by returning the appropriate value using a ternary conditional operator. The conditions for this operator are that the match must succeed, and the capture groups should contain the keys code and SKU. When these conditions are met, we return a new product info, extracting the code value and the SKU value from the relevant capture groups. In cases where the match failed or the necessary groups are missing, we return an invalid instance. That should be everything we need. One of the advantages of using Regex here is that our code is much simpler. The complexity has moved into the pattern, which more concisely expresses our requirements. To prove this works, Let's return to the test class and run the parse using regex test. After this completes, we see that all test cases succeed. That concludes our look at some of the methods we can use to return modified versions of strings. Join me in the next module, where we will apply techniques that we can use to combine and format strings.